Hi everyone, so this is question 6. Let's have a look at the question. Okay, so it says here that these figures below shows how the displacement varies with time, okay, for a system undergoing SHM. So the position of the body changes as time passes. How it changes with time is being illustrated in this figure here. Okay, the oscillator has an angular velocity of 2.0 radian per second. So let me just write it. Angular velocity is basically just omega. So omega is 2.0 radian per second. Okay, so this is a graph. I believe this is the first question that we discuss that involve a graph. Okay, when a question gives you a displacement time graph, it's equivalent to giving you an equation of motion. Actually, you can obtain a graph from an equation of motion, or you can obtain an equation of motion from the graph. Okay, so let me just write what I've just said. So the equation of motion is actually everything that you can get from an equation motion. You should be able to get it from a displacement time graph as well. Okay, they are the same thing, just represented in different way. Okay, so last time when I talk about questions that involve equation of motion, I highly suggest you to go find two things out. One is amplitude, the other one will be either omega, period, or frequency, one of them. Okay, knowing these two things is crucial for an equation of motion. So the same thing still applies for displacement time graph as well. Okay, it's the same theory for displacement time graph. So the amplitude, it's quite obvious here. This will be the amplitude. Okay, then the next thing is either a angular velocity, a period, or frequency, one of them. You have the angular velocity given to you already, so nothing to worry. You got your A, you got your omega, everything seems fine. Okay, so we can move on to solve the question maybe. Okay, so determine amplitude, period, and frequency. Okay, well, seems like this part should be quite straightforward. It will be your amplitude will be equals to 3 cm. If you prefer to write it in terms of SI unit, it will be 0.03 meter. Okay, the next thing that you need to get is period and frequency. Period is big T, but you are given omega, so probably can manipulate from here. You know that omega and T is related by this equation. You want to find T, so you rearrange your equation in the form that you need. And now it's a matter of substitution. 2.0 radian per second. So your answer should be pi second. Okay, pi second is basically just 3.14 second. Actually, I encourage you all, if it's a very clear fraction, if it's a very clear fraction, or a very clear constant, I think you can write it out like this first. Okay, it will be useful that you write out this form before you convert it to numbers, because later if you need this value, you can just substitute in pi instead of 3.14. then the answer will be more accurate. This is just what do you call it, pro tips probably. Okay, so the next thing is the frequency. Frequency is 1 over t. Okay, so this is where we apply our pro tip. Just 1 over pi. Don't put 1 over 3.14. Then answer will be more accurate. So the answer will be 0.32 Hertz. Okay. I don't think you really need to write a second here, okay, because that's not your final answer yet. Okay, so getting our period and our frequency, we have successfully solved question A. So now let's move on to question B. Okay, question B says the displacement, velocity and acceleration for the system at time t equals to 2 seconds. So they give you a specific moment, which is when time equals to 2 seconds, and they want you to find the displacement, they want you to find the velocity, and they want you to find the acceleration. 3 things. Okay, means why you input something, specific moment, you output the displacement. This is something that we did for the first question. It should involve the equation of motion. So you involve the equation of motion. So since we need the equation of motion, I believe it's a good time to construct the equation right now. So we know that the general formula is x equals to amplitude sine omega t. We have the value for our A, and it's 3. Since it's in cm and I prefer it to be in SI unit, I can convert it to 0.03 sine omega. Omega is given to you as 2.0 t. Okay, so as you can see, what I do right now, it's a reverse of what we did usually. Basically what I do now is a substitution. Substitute A equals to 0.03 and then substitute omega equals to 2.0. It's a matter of substitution. Knowing this equation, only you can start to find the displacement at a particular moment. Okay, so the particular moment we are given is at time t equals to 2 seconds. So at t equals to 2 seconds, your x will be equals to 0.03 sine 2.0. Substitute in your time, your moment. Okay, then your answer will be negative 0.023 meter. Oh, okay, so it's a negative answer. Okay, so what does it mean? If I want to check what does it mean by the negative 0.023, you can find it here. Okay, this is a graph of displacement against time. So if we finish one complete oscillation, like this part here, we finish one complete oscillation, this will be considered, the time will be considered as the period. Okay, so this will be considered as period, and as we have found here, this is 3.14 or pi. Okay, this is 3.14. Half of 3.14 is 1.57. So if I say the time is equals to 2 seconds, it should be somewhere probably around here. Okay, just a rough idea. This will be time equals to 2.00. Okay, so if I go and find what is the displacement of my body at that moment, I'll find that it will be equals to negative 2.3 cm. Okay, convert it back to cm. So this is the idea why your displacement is a negative value. It's below the equilibrium position, therefore negative value. Okay, so we are done with displacement. So now let's move on to velocity. Okay, let me draw a line. Okay, so we want to talk about velocity right now. To talk about velocity means that you want to input a moment and come up with a velocity. What you need is to find an expression that relates t and v. How do you find the expression? You have to use something that you learned in chapter 2. Okay, this is your equation of motion. I copied it back down here. In chapter 2, we learned that velocity is just dx over dt. Okay, it's the rate of change of displacement. This v here is instantaneous velocity. So knowing that, what we can do is just differentiate the whole equation. Okay, now you might feel a little bit worried, differentiate? I haven't learned how to differentiate yet. Okay, don't worry too much. It's still a relatively straightforward differentiation. Probably involves something that you learn in SPM. Okay, let's do it slowly. We have three things here. We have two things here. One is your 0.03. The other one is sine 2.0t. Okay, 0.03 is a constant. So when we are differentiating a constant, we can just factorize it out. So what will happen is we take out 0.03. And now you are left with d over dt. Whereas inside there's sine 2.0t. Okay, so this might be a little bit tricky and it involves something called chain rule. Okay, it involves something called chain rule. Chain rule is something that you learn in SPM, I think. So if it's if you are differentiating something dy, no, not good one. Let's say you are differentiating dA over dt, and the relationship between a and t is a little bit complex. So what I can do is I can split in terms of dA over dB times dB dt. Okay, so dB dB, if you combine it back, you cancel each other out, you come back as dA over dt. Okay, so we apply this chain rule here. How do we apply it? 0.03. Now we do the same thing, d sine 2.0t divided by d 2.0t. Okay, then here we call it d 2.0t over dt. Okay, so our b here is 2.0t. Now you might feel like it's a little bit messy. Well, it's definitely messy. So let's do a bit of representation. Let's say that alpha is 2.0t. Okay, so now this will be equals to 0.03 d sine alpha over d alpha. Then this will be d 2.0t over dt. Okay, then I move this a bit downward. Okay, we are applying chain rule. The pink part is where I'm applying chain rule. Okay, so if I continue here, it will be 0.03. Differentiating sign will be cos. Okay, you can think of it as d sine x over dx. So it will be cos x. In this case, the x is just alpha. Nothing much has changed. So cos alpha. d 2.0t over dt, number you can pull it out. So it will become 2.0, then it will be dt over dt, which is just 1. And so now if we combine everything back, it will be 0.03 times 2.0. Cos alpha, we bring back the alpha. Alpha is 2.0t. We bring it back here. So it becomes 2.0t. Now your equation, we have finished the chain rule. So let me go back to black. So it will be equals to 0.06 cos 2.0t. So this is your velocity equation. Okay, so using this equation, if you input a specific moment, input a specific time, what will come out will be the instantaneous velocity at that particular moment. So let's try it out. We still use the same time. The moment is at t equals to 2 seconds. At t equals to 2 seconds, if you sub in this thing, it will be equals to 0.06 cos 2.0 times 2. And if you calculate everything using your calculator, be careful enough to not making mistakes of treating it as degree. It's in radian mode. So your answer will be negative 0.039 meter per second. Okay, so this is the velocity at the specific moment where time is equals to 2 seconds. Okay, so yes, that's how I do it. If you are a bit well versed with the equation, you might be thinking of doing it another way. What you might be thinking of, I'm not sure whether you think of it that way, but let's pretend that if you think of, I'll just write this as x. Okay, you have your x here. You find your x here already, and now you want to find v. You have your amplitude. So if you are well versed with the equation, you might be thinking of doing something. You might be thinking of using this equation. Seems like another way of solving the question. Here you want to find your v, you have your, this one is given, this one you have it already, then this one you find it from here. Seems like you have everything you need to find velocity. So happily you try to substitute everything inside. 2.0. Alpha would be, what is alpha again? 0.03. Okay, it's from up there, 0.03 minus, this is your x, negative 0.023 square. Okay, if you are not sure where I get a, I get it from here. Okay, so knowing this, you can continue to solve this, and the answer you get will be plus minus 0.039. Let's compare this way of doing it, whether the answer is the same or not. Oh, okay. If you compare these two things, you see that they are having the same value. Okay, same value, but is there any issue of doing things this way? Actually, there is. Okay, if you notice carefully, here it's plus minus, whereas here is definite minus. Okay, so the problem of doing things using the second way, using the gray color way, is that I just write very clearly to avoid confusion. At t equals to 2 seconds, the system is moving in a very specific direction. Okay, it's not that you can choose whether it's going up or going down. This direction is specific. Okay, so you cannot just stop with the plus minus sign here. You have to determine whether it's plus or minus. Okay, so how do you determine it? Okay, actually to determine it is not that complicated. You see that this is the position right now, right? Afterwards, you'll be going downwards. If it's going downwards, then the velocity should be a negative velocity. So from there, you can actually determine that the answer should be negative. Okay, so technically you can still use this gray color way of solving this question. The problem is it's difficult to explain. It's difficult to explain how you get negative. Okay, and because of this reason, I actually don't really recommend you to use this. Okay, not recommended, because it's difficult to explain. I don't know whether there's any, I think there's spelling mistake. Okay, not recommended. So I will still prefer you to use this method. Get the velocity equation first by doing a little bit of differentiation. Get this velocity equation, only start to substitute and get the answer. This is how I would recommend you to solve this question. Okay, moving on. Oh, it's a very long video this time. To get acceleration, I'll just solve it here then. Okay, you have your v is equal to 0.06 cos 2.0 t. Okay, now I think you know that the steps should be similar. A is just a rate of change of velocity. Therefore, you differentiate this whole equation. If you want to differentiate this whole equation, you can see that the number is just a constant. You can bring it up. And now I'm going to do it fast. The cos, if you differentiate it, it will be negative sine. And here usually we put alpha, but because we know alpha is just a thing inside the bracket, we copy the things inside the bracket. Okay, if you find it difficult to follow what am I doing right now, do it slowly, like how I indicate earlier in pink. Just do it the pink way, don't do it fast forward. Okay, but here is a fast forward way. So now you have already differentiated the outside, you have to differentiate the inside. You have to differentiate the alpha. The alpha is 2.0 t. If you differentiate it, it will just be 2.0. So if you rearrange everything, it will be 0.12 cos 2.0 t. It's a sign, sorry, what am I doing? 0.06 times 2 is 0.12, and you have your negative in front, and you have your sine 2.0 t. Okay, so that's the equation that you are going to use. Again, let's try to box it. This is the equation you're using. So continue from there. You can just write at time equals to 2 seconds, your acceleration will be negative 0.12 sine 2.0 times 2. If you calculate everything, the answer would be 0.09 meter per second square. So that is how you obtain the velocity at a specific moment where t is equals to 2 seconds. Again, you might be thinking of another way, which is a equals to negative omega square x. Again, you will face the same issue. You'll be able to get the answer. The thing is, you'll be unsure about the sign. Wait, oh, here you have no problem. You can just do your substitution safely. Okay, this one is 2.0 square, and the x you can just copy from up there, which is negative 0.023. If you're not sure where you should be looking, you should be looking here. You can copy the x inside. So negative 0.023, and come out, your answer should be the same as down there. You should get is 0.09 meter per second square. Okay, if you are using this, you will not encounter the problem of positive negative, because the equation itself already tell you it's definitely negative. So it's okay to use this method, but in my opinion, just do the way I introduce you. Differentiate, get the equation, put in the time, get the acceleration. Okay, I would still prefer to use this method. Okay, so it's a pretty long video. To summarize what we have done, from the graph we abstract the amplitude, we extract the angular velocity. Using the angular velocity, we determine the period. Okay, we determine the period, we determine the frequency. Okay, then for B, what we do is we construct the equation of motion first. Then using the equation of motion, we substitute in the specific time, we get the displacement. For velocity, again, we derive the equation for velocity. How do we derive it? By using differentiation. We will apply chain rule to be able to derive this equation. So after you derive this equation, it's a matter of substituting in the time, and you have your velocity come out. Okay, then I don't recommend you to use this method, because it will be very difficult to explain how you get the negative sign. Then afterward, if you want to find acceleration, how? By using this equation, velocity equation, we differentiate with respect to time again. Getting this acceleration equation, what we do is again substituting in time to obtain the acceleration. So that's what we have been doing all this while. So that's all for question 6, part 1. There's part 2, which I will continue in another video. Thank you very much.